Okay, today we're going to be working in 4.4, working on exponential and logarithmic equations and solving those. Okay, and so a lot of times when we solve exponential or logarithmic equations, we're going to do it by creating the other version. So an exponential equation is any time the variable is located in the exponent, and both these cases have that true. We're going to use logarithms to solve exponential equations, but we have to be able to see the structure in the equation. For instance, the base is 3, the exponent is x, and this, we're going to call this the result. Okay? Now it's important that we get this structure written this way before we actually go to logarithmic. And so if I look at this equation, I see the base, and this whole thing up here is the exponent, not just the x, but the 0.6x. The problem is this 40 doesn't belong with the base, and so it would actually have to be removed over to be with the 240 before I could go to logarithmic method. So we need to make sure that when we're moving from one method to the other that we see these individual pieces as they are and that they've been solved down to that point. So when we're solving an exponential equation, we need to isolate the exponential term. That means the base with its exponent. We can take the natural log or take the logarithm of both sides. Essentially what we're going to do right here, we're going to call this translate to log form. Okay? And then we should be able to solve for x. So let's take an example question. And we'll always want to check our answer in these logarithmics. So here, I have a base and an exponent. That's all that should be on the left-hand side. So that makes this ready to go into logarithmic form. So I'm going to go ahead and take the log. The base of the log should be base 3, because that's the base of my exponential, of 30 equals x, because x is the exponent, and the log always equals the exponent. Now this is something that we can evaluate in the calculator. I'm going to grab my calculator and plug that in. Now there's two ways to do it, if you remember. One is to do the log of 30 divided by the log of 3, and we're going to get 3.096. So x would equal 3.096. And we're going to call that pretty good. Now, if we wanted to use the use the base structure on the calculator, I go math. I'm going to scroll down here to option A, which is log base. So I'm going to hit enter. That allows me to put the 3 here and the 30 in the parentheses. Hit enter, and I get the same answer. So the key is, once we get it in the right structure, we can rewrite it in log form, and then it goes to the calculator. Let's look at a couple of others. If we look at these examples, in this problem, the base is 5 and the exponent is x. This minus 3 is not part of the exponential. So I need to remove it from the equation before I solve. So I'm going to add 3. Okay, and I'm going to get 5 to the x equals 75. Now you might say, oh, I can divide by 5, but hold on. That 5 is part of the exponential. So it's this point when I have the base and the exponent that I'm going to go to log form. The base of the log should be 5 of and equals the exponent. Well, the exponent was x, and so the leftover 75 goes here. So I go back to my calculator. I might even just scroll up here and edit this to a 5 and this to a 75. Hit enter, and I'm going to get 2.68. X equals 2.68. Pretty straightforward, but these little things like the minus 3, they're really crucial we get them out of the way. And this question actually looks way more complicated, but let's keep a couple things in mind. There's our base. And this whole thing is the exponent, okay? Not the x, not the 4. The whole thing is the exponent. So this is going to help us for logs. But this minus 7 is not part of the exponential. So let's get rid of it. We're going to add 7. Okay, so we get 6 to the 3x minus 4 would equal 2088. Now, The rule is that now that I have the base and the exponent together and nothing else over here, I can go to log form. So this will be log base 6 of 2088 will equal the exponent. Well, the exponent in this question is 3x minus 4. And so now I can solve this, at least the left-hand side, using the calculator. And once I do that, the problem's going to become a lot easier to work with. So let's take that question up above. We should reuse that. Log base 6 of 2088. Whoops, I missed the 0. That looks okay. I hit enter. So the left-hand side is now 4.27. If that was right off of there. Yep. And that equals 3x minus 4. Well, how would I finish solving? I'm going to add 4. That's 8.27 equals 3x, and I divide by 3. So x will equal, let's go ahead and go through those steps. I said I would add 4 and then divide by 3 to get 2.76. And there's my final answer. So sometimes the exponent's more complicated, which means there's some work after I do the logarithm. And sometimes there's these things like minus 7 or plus 7 that I have to maneuver as well. So here's another example. This one's a little funny looking, so bear with me. But sometimes when we look at these exponentials, we can see that the exponent is twice as big as the second exponent. So I'm going to make this a lot easier on myself. I'm going to say that u equals e to the x, okay, which would mean u squared would equal e to the 2x, or e to the x squared, which would still be e to the 2x. So this is a substitution method we're going to use for simplifying and solving these complicated looking things. So this would be u squared minus 4u plus 3. This is solvable by factoring. This just allows us to solve some complicated looking stuff. We end up with u could equal 3 or u could equal 1. Well, if we put e to the x back, e to the x could equal 3 or e to the x could equal 1. Well, both of these are going to be a log, okay? And since I'm doing a log and the base is e, I might as well do ln, that's my base e, of 3 equals x. And over here, it's the ln of 1 equals x. Okay, and so we need to plug these into the calculator. This is a really, we do this a little bit. We don't do it near as much as might be worth our time. But x will equal 1.099 over there. And if we do the ln of 1, you should know what that is. But if you don't, we plug it in and we get x would equal 0. So we end up with two answers. This down here from here down should not be crazy hard. This up here, recognizing, hey, e to the 2x and e to the x, that's quadratic in nature because you've got double the exponent. That's a tough thing to recognize at face value if you don't know it's coming or you aren't experienced with it a bunch. We've done some, but I'm more worried about the basic stuff. Let's look at, for instance, this logarithmic equation. And now, look, the x is inside this log. Well, the only way for me to get the answer is to rewrite it in exponential form. And so I'm thinking about what exponential form looks like, and I know that I use the base again. I know that the log equals the exponent, so it must be 2 to the third, and that equals what's inside the parentheses, x minus 4. Well, 2 to the third, of course, is 8, equals x minus 4, and I add 4 to get x equals 12. Now you have to check this because you're not allowed a negative in here. 12 minus 4 is 8. That's positive, totally legitimate. So I'm okay. But you always check to make sure that works. Now this question looks hard, specifically because there's more than one log in the problem. And that does make it complicated or more frustrating maybe to work with. The good news is they're both the same base. They're base 10. And we also know from a previous chapter, 4.3, earlier section, that when there's addition between two logs, that means we multiply the insides, which would be x and x minus 3. So I can combine this into one log by saying log base 10, which I don't need, of what is x times x minus 3? And that would be x squared minus 3x. And that will equal 1. So now, all I have to do is go to exponential form and try to solve from there. Well, the base we already said was 10. Because the log equals 1, the exponent would be 1. And that will equal what's inside the parentheses, x squared minus 3x. Now, because this is quadratic in nature, I'm expecting two answers. And the way I get those answers is by setting the equation equal to 0. We've done this before. It's just been a while. You got to remind yourself when you have a quadratic, always get it equal to 0. Well, 10 to the first is 10. So I'm just going to minus 10. And I'll have 0 equals x squared minus 3x minus 10. And so I try to factor. It's probably the most straightforward way to go about it. If factoring doesn't work, I can certainly go to the quadratic formula, but it does work. Factors of 10 that have a difference of 3 are 5 and 2. A negative 3 and a negative 5 and a positive 2 gives me the negative 3. Meaning that x would equal 5 or negative 2. Now, I said earlier you need to check your answers because you can't take the log of a negative. If I put 5 in here, log of 5 makes sense. If I put 5 in here, 5 minus 2 is, or 5 minus 3 is 2. It works. Those are positive. However, if I put a negative 2 in here, I already have a problem. This can't be negative. And putting a negative 2 here also doesn't work because that can't be negative. So I have to reject the negative 2 as what we consider an extraneous solution, or extra and erroneous. So we call it an extraneous solution. So you do have to check your answers. And this, remember, there were too many logs, so because it was a plus, we combined them by multiplication. Here's another example of a problem where we're working with it. We know it's ln, so that makes it base e. Does this 3 really belong as part of the ln? The answer is no, it's an extra fact. So we're going to get rid of it before we really try to become exponential. So I'm going to divide both sides by 3. That should cancel. I'll get the ln base e of 2x. And again, I don't have to write this base e, but if you don't remember that it's there, it's nice to write it. Now I have the ln with its base and what it's taking the base of, or the ln of. Let's go to exponential form. If I go to exponential form, the base is e. The ln, the log, equals the exponent, which is 4. And that should equal what's inside the parentheses, 2x. Well, I'm going to go to my calculator, figure out what e to the 4th is. E to the 4th is 54.6. We'll just go 54.6 equals 2x, and we'll just divide both sides by 2. X will come out to be, so divide that by 2, we're going to get 27.3. And we're done. Solving exponentials and solving logarithms has everything to do with rewriting in one another's forms. To solve a logarithm, you need exponential form. To solve an exponential, you need logarithmic form. And that's our back and forth that we're going to use so much on this, this section and this test as it's coming up.